Okay, so now we're on page 70, and we're going to quickly review quadratic and parabolas, things that you've learned a lot about. But before we do that, let's talk about the family that they belong to. So in the world of mathematics, there's lots of different types of functions. A linear function where there's just an x to the first power. Well, the degree is what's the highest power on the x. Well, the x right here is only one of them, and its power is 1, which is the highest power in this case. Number 2, the constant function, there is no x. Well, if you remember that x to the 0th power is really 1, which means in here we really have a x to the 0th power, so the degree here is 0. And on the next one, the squaring function, the quadratic, the x here has a 2, so its degree is 2. And there's a whole family of functions that have powers on x, which we all know as polynomials. And then the formal definition is written right here. It says, let n be a non-negative integer such that you have a sub, and this is read, a sub n minus 1, all the way on, and that a sub n cannot be 0. Then you can have a polynomial function, which is right here. You're going to have real coefficients, so no i's, only real numbers, and then you're going to have x to some power. And if you have that, then it's called a polynomial function. So like I said, today we're going to be looking at the special family or the subset of polynomials known as quadratic functions. And a quadratic always has a degree of 2, which means the highest power on an x is 2. If you look at this situation, there is an x to the first power right here, but this x to the second power has a higher power, so its power is 2, or its degree, sorry, not its power, its degree is 2. The highest power is 2. So the general shape of quadratics is a U, and the mathematical name is not a parabola, it's a parabola. Parabola. Are the graphs symmetrical? Yes, they are symmetrical. If I were to sketch one for you really quick, draw the parent function, which you should remember. Oh, that was not a good parent function. Let's see if I can draw better on the iPad. It's a little bit better. There's my parent function. They are symmetrical with respect to the, and in this case, they're for the parent function, it looks like it's symmetrical with respect to the y-axis, but all parabolas are symmetrical to a thing called the axis of symmetry. I'm not going to be able to fit it, so I'm just going to abbreviate axis of symmetry. And to find this, you're going to use the formula x equals, not negative, but the opposite of b all over 2a. And then it says the point where the graph intersects the axis of symmetry. Well, so this, let me draw the axis of symmetry. So in this case, here's my axis of symmetry. I'm looking for this point right here. Well, that point on the parabola we know is called the vertex. To find the vertex, use the following steps. First, find the x value of the vertex. Well, to find the x value, we just use this formula that we just talked about right there. It says x equals. So we're going to do x equals the opposite of b over 2a again. And then to find the y value of the vertex, you're going to plug in x. I'm going to draw a little arrow right here because it's the x that you found in the step right above. Okay, so the parabola tells us about the blank and blank movement. It tells us about the horizontal and vertical. I apologize for my handwriting. Movement on the graph in comparison to the parent function. Please note that the vertex is only a point on the graph. The a value tells us a lot of information. So remember, if the number out front is negative, if a is negative, blank. And then it says the graph has a blank value. So if a is negative, the parabola opens down. Okay, and then the graph is said to have a maximum. Remember that vertex becomes a max or maximum value. If a is positive, the parabola opens up, and the vertex now is the smallest value, which we call a minimum value. If the absolute value of a is greater than 1, then the parabola is said to blank. Well, if that thing out front of the parabola is greater than 1, then the parabola is said to vertically stretch, and which means the parabola or the graph is going to appear to become thinner or taller, however you want to look at it. If the absolute value of a is less than 1, the parabola is said to, you can say this two ways. It can vertically shrink, so I'm going to put VS for vertically shrink, but you can fit it all in and write it out. Or it can be looked at as a horizontal stretch, but we're going to focus on this vertically shrink, which means the graph is going to appear to become wider. Okay, and then the last piece says domain and range. Well, it's very important that you know the domain for all normal parabolas is all real numbers. Please remember that we write all real numbers as negative infinity to infinity. We're not writing that R thing you learned in Algebra 1. And then it says the range has two cases, so let's look at these. So the first case right here says, if we have a minimum value, so think about it. If I draw a parabola that has a minimum value, there's a minimum, then my range is going to be my minimum and up. So I'm going to call this point right here x, comma, r for range. So that means that my range is going to be, I'm going to put a bracket because I touch it, I'm going to go from r up to infinity. My other case that I can have is the second case right here, which means I have a maximum value. And if I have a maximum value, think about it, my parabola does this. There's my dot, my vertex. I'm going to call this one x, comma, r for range. And the range here would be from negative infinity, and then the r value is the biggest thing you touch. Okay, so there's three forms that quadratics come in. Standard form, the ax squared plus bx plus c. Intercept form, a times x minus p times x minus q. And vertex form, a times x minus h squared plus k. So we're going to take a moment, we're going to look at each form individually. So we're going to start with vertex form. And you have seen this a lot. HK is the vertex, meaning the graph moved h units horizontally and k units vertically. A still has the same properties that we've always talked about, that we talked about on the previous page about a being less than 1 and greater than 1 and positive or negative. And the benefits of this form is that you know the vertex. It gives you the vertex. Okay, so example 1 says that I need to convert 2x squared plus 8x plus 7 into vertex form. Okay, so it's said in your notes, and there's a missing from the picture, but remember in Algebra 2 you learned about this thing called completing the square. So that's exactly what we're going to do. And I'm all about kind of writing down steps and following steps, so that's what we're going to do. So our step 1 is I'm going to move C. So when I move C, I'm gonna get an equation, and by move C, I'm moving it to the other side. And I'm gonna call f of x y, because those are the same thing. I'm gonna get y minus 7 equals 2x squared plus 8x. And then it says, remember that a has to be 1. Well, my a right now is 2. So to make a be 1, I'm gonna pull out a 2, but first I wanna write down the step. My next step is to make a equal 1. So to do that, I'm going to factor out an a. So I'm going to have y minus 7 equals I'm going to pull out my 2, and so now I'm left with x squared plus 4x, because you pulled out that 2, and I'm going to save myself a step, and I'm going to add in a plus blank. And when you add a blank on one side, remember this is an equation, so it has to be equal, so we have to add a blank on the other side. And then my next step is to fill in blank. And to do that, I'm going to grab another color. I'm going to highlight it in red. But to fill in that blank, this magical blank right here, there's a formula. We use b over 2 squared. So my b right now is here, it's 4. So 4 divided by 2 is 2, and 2 squared is 4. Be so super careful. Let me go back and grab my green really quick. I'm going to add a 4 right here, okay? I'm going to add this 4. Remember, this is an equation, so if you add it to one side, you have to add it to the other, but you did not just add 4 here. This 4 that you added that's right here on this green line that I'm drawing is in parentheses, and it's going to get multiplied by a 2, which means over here on the other side, you really have to add an 8, because 2 times 4 is 8. Okay, and so now our next step is to complete the square. All right, CS, complete square. So what you have right now, and I'm just going to clean it up, you have y, a negative 7 plus an 8 is going to be a plus 1, equals, now you have to factor this side. Well, the 4 that you added makes this the perfect square so that you can factor into x plus 2 squared. And I'm just going to rewrite it really quick. It's y, which we had f of x, those are equal, equals 2x plus 2 squared minus 1. I subtracted the 1 back over. So now if I wanted to graph, let's see if I can do this real quick. I'm going to make my, I'm going to zoom way into my graph really quick. And I'm going to remember that my parabola, be very careful. It's backwards inside the parentheses, remember. So my vertex, I'm going to write this right down. Vertex is negative 2, negative 1. So if I zoom in to draw my vertex right here, I'm going to draw a dot at negative 2, negative 1 right there. And then, let me zoom back out really quick. Maybe not make it so sideways. I'm trying. The a value up front was 2. So what I'm going to do is show you a cool little trick. So you can plug points in, but normally if you think about a parabola, when you plug in 1, you're going to square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9. A parabola has what I call a 1, 4, 9 pattern, which means you can go over 1 and then up 1. You can go over 2 and up 4, or you could go over 3 and up 9 and find your pattern. However, this time I have a 2 out front, so you have to multiply that 1, 4, 9 by a 2, so now it becomes 2, 8, and 18. So what we're going to do is I'm going to go over 1, and instead of going up 1, I have to go, instead of going up 1, I have to go up 2. So I go over 1 and up 2 from my vertex. And then I can go over 2 and I have to go up 8. Remember, from the vertex. So there's one side. And if you remember, the parabola has this magical green thing called the axis of symmetry. So if you have a point on one side, you have a point on the other. So now I can try to draw my parabola. Again, I'm not an artist, so not the best. But there is my parabola. Okay, the next example says I need to convert. Now I'm going from vertex form back to standard form. Well, instead of completing the square, we're going to multiply it out. So you might write that in your notes. To go from vertex to standard, you need to FOIL or multiply it out. So I'm going to leave my the 0.5 or my 1/2 out front. And I'm just going to FOIL the first piece, the thing in parentheses. And so when you FOIL this out, you're going to get x squared, x squared plus a 4x plus a 4, and then minus 6 on the outside. And then I have to distribute my 1/2 in, so y is going to equal 1/2 or 0.5 x squared plus 2x plus 2 minus 6. And then y equals 1/2 x squared plus 2x minus 4. Well, so now we know some really cool things. First thing we know, we can use the top form up here, and we know that our vertex really is -2, -6. We also know something very awesome about this value right here. That is our y-intercept. So I can do y-intercept, and it's going to be 0, -4. So -2, -6 is my vertex. 0, -4 is my y-intercept. So let's see if we can go over here and draw it. So -2, -6 right here is my vertex. And then we just talked about how, I'm going to just double check. Oops. Zoom back out. My y-intercept was 0, -4. So I'm going to go draw 0, -4. And so if we have a dot there that's 2 over, we know that we have another dot on the parabola right there that's 2 over. And without doing any more work, using what we know from two different forms, standard and vertex, there is my parabola. So now we're going to look at intercept form really quick. P and Q are called the blank or blank. They are the root. This means that the x-intercepts of the equation are P0 and Q0. A still the same properties as before, and the benefits of this form is it tells you the x-intercepts. And then I need you to write down a formula for me on this page. So remember before when we were given standard form, we had standard form, we used a formula that said x equals -b, or the opposite of b, over 2a to find the vertex and the axis of symmetry. Well, there's a formula for intercept form that's very similar that will get us the vertex. If you think about it, halfway between the two intercepts, you should be able to find the vertex. So that's exactly what we're going to do, is we're going to average this distance. We're going to do P plus Q over 2 is going to give me my x value of my vertex, which is also going to be my axis of symmetry. And if you remember before, once we have the x part of the vertex or the axis of symmetry, we plug that in to find the y value. Okay, so this example says that I need to convert 1/4 x minus 3 times x plus 1/4 into standard form. So I'm in intercept form, and I need to find standard form, which means you're going to multiply it out. So I'm going to do y equals, I'm going to leave my 1/4 out front real quick, and I'm going to FOIL this other stuff together. So you're going to get an x squared. First of all, I know that my intercepts are going to be at 3, 1, 2, 3. And at -1/2, so if I put that at 1, there's -1/2. And I know that this parabola opens up. I also know that halfway in between these two, I should have my vertex, so probably somewhere right in here. And the other thing I know is that my y-intercept is going to be -3/8, which is going to be like right there. So we could find our vertex. I'm going to x equals, let's do that really quick. So I'm going to have a 3 plus a -1/2, all divided by 2. So what I have is x equals 2.5 divided by 2, which x equals 1.25. So like probably right there-ish, I'm approximating. And then you can just sketch out your parabola. Okay, so the last part of these notes asks some questions, but we have one more example to do, and it says that I need to convert -4x squared plus 24x minus 32 into intercept form. So I'm going to shrink this picture and kind of put it up in the corner, and we're going to do this step by step. So the first thing I have is I have y equals -4x squared plus 24x minus 32. And I hope you remember the first rule of factoring is always to pull out the GCF. So I'm going to have y equals, I'm going to pull out a -4. I'm going to get x squared minus a 6x plus an 8. And then I'm going to do y equals, I leave my -4 out front, and now I can factor so pretty because I was very nice and gave you a nice problem. X minus 4, x minus 2. And so now I've gone from standard, from, standard form into intercept form because I factored. And so now I know that my intercepts are 4, 0, and 2, 0. And if I need to sketch a graph, I could. The next question says, what would you do if this did not factor so nicely? And this is where you need to make sure you write this formula down because I will never, ever give it to you again. You have to know the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And in case you don't know, but you should, y equals ax squared plus bx plus c is where the a, b, and c come from. And then the last thing that I just want to talk about on the bottom of page 73, it says, what's the difference between factoring and solving a quadratic? Factoring is simply, and I'm going to write on the problem that I just did, this is factoring. I just factored it. I rewrote it. Solving is where you get things like this and like this, because you take each factor and you set them equal to 0 to find out what x would be. So if it says to factor, you only can factor. There is no x equals or x intercepts. It's just simply x minus 4, x plus 2, whatever it is, something like that. If it asks you to solve, then you take the factors that you found and you set them equal to 0.